So I don't know if you people have realized I'm kind of a nerd, and I like to do a lot of research and just figure out why things are the way they are and how to improve them and such. But let's just go through the University of Maine. Oh, PDF. You know how much I love these. This activity provides an opportunity for students to investigate how thermal expansion of water affects sea level rise. This is suggested lab activity allows students to observe and describe the change in the water level in a container when the water is exposed to heat. Pardon me. Big idea. Increases in the atmospheric concentrations of the greenhouse gases carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons are expected to result in substantial global scale warming in the future. In response to this warming, global mean sea level will change in part due to thermal expansion of the oceans. In this activity, global warming is not being shown, rather thermal expansion of water is used as a valid and simple activity to demonstrate that an increase in temperature can cause sea level rise. In the context of oceans, thermal expansion is the increase in volume or decrease in density of ocean water as a result of increased temperature of the water. As a rise in global sea level due to the warming caused by the greenhouse effects could probably be caused by only two effects: thermal expansion of the water column due to the decrease in water density caused by its warming, and the addition of water volume due to the melting of glaciers and ice sheets. Changes in sea level affect habitats and the flora and fauna they support. Habitat is flora. I think those are like organisms, right? Oh, figure that one. I'm pretty sure I'm right on that. But freaking, if you don't know, go look. What might cause essential questions? What might cause sea level to rise? What kinds of problems would you expect to see? That's just poor grammar, especially for a freaking university. What kinds of problems would one expect sea level rise to cause? What information would we need to know? And so now it's going. So, what kinds of problems would we expect sea level rise to cause? What information will we need to know to plan for the rise in sea levels on Earth? Does water expand in response to temperature change? How are humans contributing to the sea level rise? What actions can we take to counteract our impact on climate variability and change? See, I don't think that's gonna tap into what it is that I'm looking to. So hold on a second. Okay, so let me pause it for a moment. What I'm trying to get at is when we compress a snowball, we can get water out of it because there's compression causes atoms to rub against each other, making friction. With that, if we add a certain amount of water onto certain sea levels, in the oceans, let's just go to ocean's greatest depth, producing energy. Not deep sea ocean, deep sea, exploring the deep. Ocean's greatest depth. let's just go with that. The Challenger Deep in the Mariana Trench is the deepest known point in Earth's oceans. In 2010, the United States Center for Coastal Ocean measured the depth of the Challenger Deep at 10,994 meters, 36,070 feet. And so that's roughly about between 6-7 miles. Let's see, it's like probably closer to 6,000 miles, or 6,000 miles, 6 miles, I should say. No more than 6 miles. So, what happens when you put water under intense pressure? Let's just check this one out. Only a couple people have really researched it. Pretend you have an indestructible tube that cannot leak inside, which is water. Imagine that in each of the tube you have very powerful pistons. What would happen if you compress water inside? Would it turn heat and escape the tube? Would the water turn into a solid because the water molecules are so close to each other? Would the water turn into a black hole? What would happen? At this point, but truthful answer, no black hole, and water is very, very incompressible. Water at 40,000 megaspheres? Is that what it is? I don't know what MPs are. Only has a 1.8 decrease in volume, and not a lot would happen. See what happens to water under high pressure without the possibility of escape, and hypothetically, what happens to water as pressure increases to infinity. It's funny how the answer on chemistry site is more detailed than the answer here. I hope someone will add a higher quality answer to this question. The highest rated answer on the chemistry site implicitly assumes that compression increases temperature, which is not necessarily true. The pressure and temperature of a system can be controlled independently. Does water pressure increase with water temperature? No, hold on. How does pressure affect the boiling point of water? Raising the atmospheric pressure will raise the boiling point. Conversely, lowering the atmospheric pressure will lower the boiling point of the liquid. This phenomenon is due to the fact that the vapor pressure of water is temperature dependent. I don't know if I'm satisfied. Superheated steam explosion and heat inlet. How can you boil a liquid without heating it? Why is this possible? This is going to be a good one. Oh my. The change in the heat of fusion of water with temperature has a maximum at minus 17 degrees. This strange behavior has been determined from the variation in specific heat capacities of ice and water. It is due to the changes in the structuring of supercooled water. As the temperature is lowered from 0 degrees, the hydrogen bomb strength of ice increases due to the reduction in their vibrational energy, and this gives rise to an increasing difference as the temperature is lowered between the enthalpies. I guess that's the way water perceives its environment. I'm thinking like empathy. I'm probably totally wrong on that. Pardon me. So between the enthalpies of water and ice, at low temperature below minus 17 degrees, the continuous shift with lowering temperature in the supercooled water towards the ES structure. Electron structure? No, that'd be redundant. Reduces the enthalpy of the water relative to ice due to the consequent increase in water has the highest specific heat of all liquids except ammonia. Okay. I'll learn. Thermal expansion rate of water, hot water expand. I'm gonna have to do a little bit more research into this, but but I know I'm onto something here, and once again, I'm just gonna show you another video. So yeah, this is a really interesting experiment. I mean, because the thing is that if we decrease the pressure upon the water in a contained system, and for instance, Earth, where there's glaciers, there's liquid water, and there's clouds of vapor water. And so, essentially, if we compress things, they're going to heat up so much that they start to cool off, and well, it's going to be situations like this. I mean, and that's why water is it's virtually indestructible. And, if we're ever going to create a real spacecraft, we're going to be using water as part of a force field and whatnot. I mean, and that's the thing is, you look at these meteors, and I mean, the best thing to do is freaking have something like the moon, like to bore inside the moon and fucking put an engine on that thing and drive that thing through space, but it's going to wreak havoc on the Earth. And maybe that's why Mars doesn't have a moon, because freaking previous civilization already did that. There's nothing new under the sun, and so that's the thing is that raising the sea levels, just the pressure will cause heat, and so the oceans will start to boil from below. And that's the thing. And how long has this been actually happening? Because the other thing is that we just looked at the Challenger Deep, Marianas Trench, and I mean, you dig down 3 feet in a lot of areas, the temperature stays about 55 degrees. And in certain areas, there's permafrost and whatnot, and it stays below freezing. So that's what we have to start, climate change is not just one way, man. No, it's not. Absolutely not. And people really need to start waking up. And how about you start looking at the nuclear test that we've done, and how we've disrupted the oceans, and how we freaking disrupted our atmosphere, blew holes through our atmosphere. And you want to tell me that they didn't do any freaking nuclear testing in Antarctica? Freaking, well, Truman killed freaking over 100,000 civilians. I believe that's how many. I mean, I don't know how many people died in Japan. I can't remember. I've heard the number a bunch of times, but it's nothing compared to the Jews. They were 6 million of them died. So, anyways, take care, be safe, be kind, stay strong. Love you all.